All right, so we're looking at this shape that's referred to as a conic, and we're considering where a plane intersects it. And like I said, we're not going to get into really the study of the conic specifically, but we're looking at a section of the conic where a plane intersects it. And like I said, if we look at the first of the three pictures at the top of page 636, the result is we have a circle, we get an ellipse in the next picture, and we get a parabola in the next picture. So those are what we're considering, but we're considering a circle, which we've done before, and we're considering parabolas, which we've also considered before, and we're adding ellipses to this discussion, but we're considering them as they relate to what the definition of a locus is. So if you look down at the bottom of the page, we're told that a locus without the T, so we're not talking about a grasshopper. A locus is it's just a collection of points satisfying a certain geometric property. And really the term locus is just another term for collection, all right? But that's how we're going to consider these, how we're going to define each of these shapes, a circle and a parabola and an ellipse. We're going to define them as a collection of points satisfying a certain geometric property. And it'll make a little more sense how that differs from, like, for example, a circle, how we looked at it before when I write down the definitions of these. So let's start with circles. And see this definition as it pertains to this idea of a locus. And when we write the definition that way, we say a circle is a set of all points. Set of all points x, y in a plane that are equidistant from a fixed point HK called center. So nothing groundbreaking so far, right? When we had our equation of a circle, we remember this point HK, we have a center point called HK, and it makes sense to us that all of the points on the circle are equidistant from that center point, right? So we've got a shape, looks like this, HK in the middle, right? Whatever point we choose here, we choose a point there, we can choose a point over here, and this distance, which in a circle, of course, we call the radius, is going to be the same regardless of what point we pick on the edge of our circle, right? So the distance are between the center and any point is called the radius. All stuff that we know so far, right? Stuff that we're already familiar with. And so we have a standard equation for a circle, which again is an equation that we've learned before. So standard equation for circle is x minus h squared plus y minus k squared equals r squared, where hk is center and r is radius. Right, so we've had that definition before. We've had that equation before. We're already familiar with that. Also, just note, we're going to see that they're going to give us this, make sure that we're aware of this in each of the shapes that we're looking at. If HK, if the main point of interest is at origin, then equation is x squared plus y squared equals r squared. And when we say it's at the origin, what do we mean? HK would be what?
The center.
Huh?
HK is the center, right?
Yeah, but I mean, what would, if we say if HK is at the origin, what point is that?
0.
That's 0, 0, right? We're just saying if H is 0 and K is 0, then that would be the formula.
Wait, what does that say? If HK is what?
If HK is at origin. Okay. So if we look at example 1 on page 637, I'm not going to work this out because I think should be so familiar to us, and we should already really know how to do this. They give us a point on a circle and they give us the center of the circle, and they said write it in the standard form. And so for this equation here, H is equal to what? For these set of points here, what's H equal to?
-2, -3.
H
H is -2.
is -2. K is equal to -3, right? And so if we plug that in the formula, it would just be x minus -2, all of that squared, plus y, what was it, -3?
Yes.
Y minus -3 squared, right? You got to make sure you maintain these negative signs here. Equals r squared. So this becomes here x plus 2 squared plus y plus 3 squared equals r squared. How do we find r? We use something that we learned way back in geometry, just the distance formula. If we have 2 points on a coordinate plane, we can use this distance formula to find the distance between those 2 points. And if you remember, the distance formula is which would be our r in this case. It's just going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Right? So you take the difference of each of the points, square those, add those together, and then take the square root of it, and that'll give us our r. And so in this case here, we end up with the square root of 58 for that value. And so what's the square root of 58 squared? If r is that, the square root of 58 squared is just 58, right? So this would be a formula. I said I wasn't going to do it, and I did it anyway. But we went through it really fast. So did I lose anybody with that discussion? Does that all make sense? As far as sketching a circle goes, which is what example 2 asked for, in that one they give us an equation. And again, I'm not going to do all the details here, but the point to this, if we're going to be able to easily sketch it, the way to easily sketch this, guy, is to put it in the standard form, right, of the equation for a circle. So that's what we've got to do. And so we would basically take the x squared minus 6x plus y squared minus 2y. We would group those sections together. And to me, you can go ahead and move this over. You can say put the -6 over there. So we'll get all of our terms with the variables in it on one side, and we'll get our constants on the other side. And so we've got to make it look like this form here, right? So do you guys remember how we did that when we were working with the equation of a circle before? Remember how I could turn this into an equation that's got x at the beginning and the whole thing squared, and turn this into one where we've got y at the beginning and the whole thing squared, binomial. You guys remember the trick? Yes?
So,
Hey? Huh?
I mean, I don't remember exactly how to do it. But
I'm looking for a specific phrase. It's like complete the square. Yeah, so we're going to complete the square, right? Do you guys remember that? So when I complete the square with this, I get x squared. How do I complete the square? I take half of this middle term, and then I square it, right? So this stays 6x, but then half of that, which is 3, squared is going to give me 9, so I add a 9 in there. And what happens when I do that is that allows me to then say this is going to be x minus 3 squared, right? And I would do the same thing with my y here. I take half of the middle term, which is 2, so that's going to be 1 squared. So y squared minus 2y plus 1. And that's going to then turn into y minus 1 squared. Right? Did everybody see how I did that with completing the square?
yes.
But what's the problem? I've added some values in that weren't there before. So in order to make sure that I haven't changed the overall equation, whatever values I added in, I have to do what?
Add them to the other side.
I have to add them to the other side as well, right? Or you can think of it subtracting them out from this side, however you want to think about it, right? But it's kind of easier at this point to just add them to the other side. So we got negative 6 plus 9 plus 1, because those were the numbers that I added in. And so now I've got x minus 3 squared plus y minus 1 squared equals 4. And so we can say that our h is 3, our k is 1, and our radius is the square root of 4, right, which is 2. And so then that's really easy for me to plot on a coordinate plane. Everybody understand that? Like I said, this part's really reviewed. We had to do the same sort of thing in the previous chapter. All right, what about finding the intercepts? That's the last example. Any questions about this? No? Okay. Remember, I can't help unless you say, yeah, I'm confused. You gotta tell me. You gotta tell me before the quiz comes, Diego. This is the point at which you go, you lost me. Could you go through that one more time?
I just forgot the formulas in the quiz. I couldn't remember
You forgot what?
the formulas. I couldn't remember how.
Well, like this is the only formula we have so far. So what formula? Are you talking about the quiz? Okay, gotcha. All right, so one last thing. They ask us to find the intersections with the y-axis and with the x-axis. So that's the next problem. So if this one again, this is just an algebra exercise. So I'm not going to go through it, but basically, just make sure you understand to find x-intercept. If I have a graph that's crossing the x-axis, what is my y value going to be for each of those points? Huh? 0, right? So to find the x-intercepts, set y equal to 0 and solve for x, right? And the opposite is true for to find the y-intercept. If it's intersecting the y-axis, then x is going to be 0 at that point. So set x equal to 0 and solve for y. Right? And so in the case for this circle that they give us here in this problem, there are 2 x-intercepts. We'll get a square. When we take the square root, you'll do plus and minus for the square root, and so it intersects the x-axis at 2 places, but it only intersects the y-axis at 1 place. And so y will equal 2. Remember though, this is a graph on a coordinate plane. It's possible that there are no places that the equation for the circle intersects the y or the x-axis, right? So recognize that that's a possibility. And in those cases, you get an equation which isn't true. Like variables would go away and you get an untrue statement or something like that. So that would tell you that there were no x-intercepts and no y-intercepts. Questions about this? Does that make sense to everybody? Yeah? You sure, boy? All right, all right. You're shaking your head, yes, but I'm kind of looking for I'm shaking with a smile. It's like, yeah, I get it. All right, so let's move on to parabolas. Again, something that we've looked at before. What was it that we graphed and was the equation, the equation was a parabola?
Quadratic equation.
Quadratic, yeah, so when we had a quadratic function, it would have a graph that was a parabola. So we have looked at parabolas before, but now we're going to think about parabolas with this idea of the definition, here when we talk about a locus, these collection of points. And we're going to see a definition of a parabola that we haven't really seen before. So I don't think it gave us this definition in the previous chapter. So what is a parabola? As we think about the locus. Parabola is a set of all points xy in a plane. I can't help it, I think of like an airplane with all these xy points. That's just what I think of every time I write that. Just hanging out in there, chilling, that are equidistant from a fixed line which we call the directrix and a fixed point which we call the focus. Is not on the line. The midpoint between focus and directrix is the vertex. And a line through the focus and vertex is the axis.
What does that say after the midpoint? Is the midpoint something like
The midpoint between.
go between?
Yeah. Right, so this drawing here kind of gives you a visual understanding of what the definition is saying. Right, so we're familiar with axis. We talked about the axis whenever we discussed parabolas before. We recognize that there's this line that intersects and goes through the vertex, and the parabola is going to reflect across that axis, right? So we're familiar with that definition. But what this introduces is the idea of a focus and a directrix, which means that wherever this focus point is, if I take any point on my, and I haven't done a good job of drawing it to scale, so the distances look a little bit off. But if I take any point on my parabola, right, like this point here, and I draw a line from that point to the focus, and I also draw a line from that point down to the directrix, those two distances are going to be the same, right, whichever point I choose. And so that's really what those points of the focus and the directrix represent. And so what should be obvious to you as well, that one of the points we could draw it to is where the vertex is. And so that means that this distance here, right, and this distance here, the distance from the vertex to the directrix and the focus are going to be the same, right? Now, well, let's do the standard form, the standard equation for a parabola. And we've got two different equations here depending on whether or not our parabola is open and upward or downward, or we could have a parabola. One of the things that we didn't really consider whenever we looked at parabolas before was a parabola that might go like this. Do you remember why we didn't consider the ones that were like that? It failed the vertical line test, which told us that it was not a what? Function, right? So we were looking at functions when we considered parabolas before. Now we're not so concerned about functions. We're just concerned about the definition of a parabola. So you could have a parabola oriented this way, right? It has an axis right here and a vertex right here, and could have a focus here and a directrix here. So your parabola could be oriented like that. And so what?
So it would still do all of the same things that a parabola does, it just wouldn't be a function, right?
That's right, it wouldn't be a function. And so because of that, we're going to have two different equations for the standard form of a parabola. Okay, one where it's oriented up and down, and the other one where it's open and left or right. So the first one is x minus h squared equals 4p, and we'll define p in just a second here. Y minus k, where p does not equal 0. And this is when we have a vertical axis. And in that case, the directrix is going to be y equals k minus p. Because remember, if we have a vertical axis, then the directrix is going to be parallel to the x-axis. And so it can be defined as just a line which has a value of y equals k minus p. Now, when we have a horizontal axis, the function is going to look like this, or it's not really a function, actually. But the equation is going to look like this. Again, p cannot equal 0. And this one is going to have a horizontal axis, and the directrix is going to be x equals h minus p. I need to. Does anybody have a black pen on them by any chance? Black ink pen? get one? Make a note here. Thank you. Thank you. As far as P, we say the focus lies on an axis P units, and this is what I had to add into my notes. This is a directed distance. By directed distance, what we mean is we're going to include the sign. Like normally when we deal with physical distances, we throw away a negative sign if we get a negative sign in our answer, because it's like the distances, we consider that to be the absolute value, and you know, in the physical world, we don't think of those distances ever as being negative. We always think of them as being positive. But in the case of P, we're going to let the sign tell us which direction it's going. Okay, that's what's basically going to help us understand if it's opening upward or downward or left or right. Okay, so this is a directed distance, P units from the vertex. And then, you know, similar like to what we had before, if vertex is at origin, then just realize that the formulas become x squared equals 4py, or y squared equals 4px. And that's just recognizing that h and k will be 0 in those cases, and that's the formula that we'll get. All right, before we kind of dig into some examples, I just want to make sure that we understand what this is saying. And I think kind of the easiest way to see it is by looking at the pictures that they put at the bottom of the page, 639. Like the whole idea with a directed distance, you can see that with the P, and they say if P is greater than 0, right, for this guy here, if P greater than 0, then it opens upward. If P is less than 0, it opens downward. So you see, as we take as we figure out the value of P, which is K minus P in this case, and which is with P being the distance from the vertex, the distance of the focus from the vertex, then if P is going to be negative, it makes sense that the focus is going to be below where the vertex is, right? And so with a negative P, it opens downward. Similarly, with this guy here, if P is greater than 0, then it opens to the right. And when P is negative, less than 0, opens left. Because the focus is a negative distance from where the vertex is. Okay? Does that make sense to everybody? We're going to go through just a few quick examples here, and we're not going to get to section 9.2 today. Should have cut you guys off sooner on that quiz. I'm just too nice. Just too nice. I suffer from niceness. Not quite as nice as Hayden wants me to be, right? Finishing the school year early, but.
Just 1 week early.
Huh? 1 week early?
Just 1 week.
Well, we just lost that week, right? Because now we're having to do 9.2 later.
And then next week we have a short. We don't have a quiz. So then we have a combined quiz of 9.1, 2,
Well,
and 3.
I don't know. I may go ahead and
Well,
give you a quiz over this because we're going to be gone a week, the following week. So I may go ahead and quiz you over.
Well, next week. Oh, the week after next week's spring break.
What's that?
I was just gonna say, you could just give us the test after we learn 9.2.
Yeah. And then you
That
take it to
way-
spring, but then I don't give you an opportunity to be quizzed on that material.
Yeah.
It is just one section.
Opportunity.
And, but anyway, we got to get through this section first, so we can discuss that later. But yeah, I think I will still give you a quiz over 9.1 next week, just so you can practice some of these questions. All right? So the standard form of the standard equation of a parabola. Here's an example using that, and they give us the vertex, and they give us the focus to be 0, 4. The vertex is at the origin, and so we're looking at an example where it's going to come down here like this, right, and cross right here at the origin. That was a terrible parabola, but you guys know what I'm trying to do. All right, let's just do this. Let's just move our. That's a little better. And it tells us the focus is at 0, 4 up here. So if that's the case, and this is our vertex at 0, 0, then we know that our p-value is what? How do we determine the p-value? Remember, the p-value is the distance of the focus from the vertex. From the vertex. And so how many units is that?
4.
It's 4 units, right? So p in this case is going to equal 4. It's a directed distance, and so it would be 4 minus 0, which would give us the p here. If it had been 0, negative 4, then it would be negative 4 minus 0, which is going to be, we'd have a negative value for p, right? So p is going to equal 4, and so we have everything that we need for our equation, right? We can use this simpler guy here and just say that x squared equals 4 times 4y, or x squared equals 16y. All right. Now, if I want to check this on my calculator and verify that it matches this graph here, remember with your calculator, you're always saying y equals something. So you're going to have to solve this guy for y. So what you enter in your calculator is going to have to be y equals x squared over 16. So if you enter that in, you should get a graph that looks like the graph in the book there. Did you guys get something like that? Sean did pull out his calculator. He's like, I'm just doing it in my head, man. Yeah, that works. I see it.
Wait, how do you know what P is?
Because it's the distance between the vertex and the focus.
So you're using the distance formula to find it, right?
Yeah, but this one's so simple we didn't
Yeah.
really need to. But yeah, if you had to, and it will always be. You know, you don't really need to use the distance formula because it's always going to be either a vertical line or horizontal line. So you only have to worry with two values, right? The difference between two values.
So like if it was 2, 4, would P be 6 or would it still be 4?
If this was 2, 4.
Yeah, it would still just be 4, right?
All right, so these problems are always, it's going to either be a vertical axis or a horizontal axis. So if this was 2, 4, then the vertex down here would be 2, 0.
2, 0. But so then P would still be 4, right?
That's right. That's right.
And then it's the same thing for like horizontal, right?
That's right. It would always be a horizontal line, so the x value would be the same for both points, right? Yes.
If the parabola shifted up 1,
Mm-hmm.
would the focus then be 0, 1?
If the parabola shifted up 1, then we would have to use this focus here. This focus here would be 0, 5. If it was this parabola, it would be 0, 5, and this would be 0, 1. Yes. Make sense?
I thought it was the focus was always the same distance. Oh. I don't know.
If it's this equation, right, if it's this parabola, if we took this exact same parabola, but then we shifted it up 1, right, then each of our points here move up 1. So this becomes 0, 1, right, and this becomes 0, 5, all right? And then, so our parabola is going to look like this, and then we can't use the simplified formula, we got to use this formula, right, because h and k aren't 0. But p would still be 4, because it's still just 5 minus 1. I'm sorry, I crossed out the wrong one there. I should have crossed that one out. Still 0, 1 here. This one is not the same. Okay? So p stays the same. And there's actually, well, we've got an example here. We're running out of time, but let me just kind of explain these last two problems. Does that make sense to you, though?
Yeah, I was thinking about something else. It's
Okay.
the directrix or whatever.
Yeah,
It's always the
directrix.
same distance from that.
Yeah, the distance to the directrix will always be the same distance as the vertex to the focus. So
Yeah, I was thinking the x-axis was the direct.
okay, gotcha, I gotcha. So find the focus of a parabola that's given by this equation: y equals negative 1/2 x squared minus x plus 1/2, right? And you're gonna have you got to get this into standard form over here. And so we're going to take the first thing that they do is they multiply everything through by 2, so we can get rid of these confusing fractions. So we're trying to make it look like, well, which one am I using? Am I trying to make it look like this first equation or this second equation? Because I'm going to match one of these. Is this parabola here going to be one that's opening upward or downward, or is it going to be a parabola that's opening right or left?
It's gonna be opening upward and downward, right?
How do I know that? Based on that equation.
Because we're doing y equals.
Not necessarily. I could have written this as x equals, and it still would have opened downward if I'd rearranged the formula and said x equals. Here's the key. Notice in this formula, x is a squared term. In this formula, y is not, right? So because we've got a square on our x, we know we're dealing with the first formula.
Okay.
Okay? So let's multiply through by 2 to get rid of our fractions. So now it looks simpler, right? Did I do that right? No, I didn't. It should be a 1. Is it minus? They multiply through by -2. Why did they do that?
Multiply each side by -2. So it's just x squared plus 2x.
Oh, I missed this. I missed that there was a negative here.
Yeah.
My bad. Yeah, so if we multiply through by -2, then this becomes positive, this becomes positive, and this becomes, there we go. All right. And so then we get everything that's, we basically are going to move this 1 over here so that we now have 1 minus 2y equals x squared plus 2x. Why did we do that? We did that because we're going to have to complete the square so that we have something that looks like this in our formula, right? So once we've simplified it, we get everything that doesn't have x's on one side of the equation, and then we complete the square. So 1 minus 2y equals, completing the square here gives us x squared plus 2x. Half of 2 is 1, squared is going to be that, right? But since we added a 1 to that side, we're going to have to also add a 1 to this side, right? And so this becomes 2 minus 2y equals x plus 1 squared. So we're pretty close, right? We just rearranged, we're trying to match this one here. So we'll flip it just so we can see that it looks just like the one over there. X plus 1 squared equals, we factor out a negative 2 here so that we can, well, let's rewrite it like this. Let's write our y term first. So we've got negative 2y plus 2. Because that's the order that it is here. We've got y minus k. So we factor out our negative 2. So we've got y minus 2. Is that right? No, minus 1, sorry. I just want to keep doing that. Right, so that is our, that matches our equation. So now that we've got it in this form, we can say that our h is what?
H is 1.
H is negative 1, because the formula has a negative in it, so h equals 1. K is going to equal 1, because we've already got a negative sign there.
You put H is 1 equals negative 1.
Say that again? H is
H is
negative 1.
1,
Yeah, I
so-
said it and then didn't write it. And what is P? Well, we know that 4P equals negative 2, right? And so then we could divide by 4 and say that P is equal to negative 1/2, right? So that would be changing that equation so that it matches standard form, and those would be the values, and we could figure out where the focus is using this formula here, or where the directrix is. Directrix is k minus p, and the focus would be in the opposite direction, k plus p. All right, I'm out of time for finding the standard equation, so you guys can look over that example and let me know if you have any questions over that next week. All right, sound good? I would look at that example though. In your homework will give you some opportunities, but that example shows you a situation where it opens to the right? So your axis is horizontal. So. Have a good day.